Hello.
Hello, are you there?
Hello.
Hello, are you there?
Yeah, I'm here, but for some reason I'm not seeing the video. So
I'm
let's
not either.
um,
Let's
shoot.
see.
Oh, wait.
Oh, there you well,
There we go.
there you go. Can you see me?
Let's see. Hold on a second. No, I don't see you, but I see me. Let's see.
Yeah. How did you undo your video?
So for some reason initially it was just, let's see. Hold on one second. Oh, I see.
It shows my video is being crossed out.
Yeah, let's see if I can change that. Um,
Oh.
oh,
There we
wait.
go.
Yeah.
Can you see me now?
Yeah, I
Oh,
do.
hi. Great.
Oh, how are you doing?
I'm great. How are you?
I'm well, thanks. So, how's it going with statistics?
Well, um, well, I think I'm doing great, and then I take the homework quiz, and I'm not doing so great.
Okay.
I
Well,
have a question. Yeah, I'm gonna be sending you an email about last week's because there was one whole section that I have no clue what I did wrong, and so he told me just to email you, and maybe you could help me figure out what I did wrong last week
okay. Yeah.
on one of the sections because I missed a bunch of them on there. So, um, on this week's homework, but I have a question on 6.1.
Okay.
The question number 44. And my question is really kind of a strange question, I guess. When you're looking at the table and you find in the number, which I think I did right,
Mm-hmm.
is everything to the left of the zero negative on the charts? It's
Um,
on finding the z values.
right. Okay. So let me get up to speed. So, which problem specifically are you working on? You said it was from 6.1.
6.1, question 44.
If I have that. 6.1. Can you just read me the problem?
Yeah, it says, well, it's got a box and it says find the z values that correspond to the given area. And it has the little graph, and the numbers are, it gives you the zero, and then it gives you the z, but you have to find the z value. And the number in the shaded is 0.9671.
Okay. All right. Yeah. So I've got it. All right. So this is a normal distribution, and in
Mm-hmm.
fact, it's not just any normal distribution, it's the standard normal distribution. So it is one that is centered at 0, with a standard deviation of 1. And yeah, so we have a particular area under the curve, 0.9671. Yeah, and you're asked to find the corresponding z-score.
Right.
And so
that was the only one that I really had problems with. Well, I didn't really have problems with it, but I was kind of confused if I was actually doing it right.
why don't you just tell me like what your approach was, and we'll see. Maybe you are.
Yeah.
So
Well, I
what was
went
your
that
approach?
the 0 was the, I'm sorry.
So just kind of walk me through, like what was your approach? How did you go
Well,
about?
I found the 9671, or what was closest to it on the chart, and it
Mhm.
came out with the z value of being 0.8. And then so I subtracted the 9671 from the 0.500, which is the value for z, or for the 0.
Mhm.
And then that came out with 4671, which was also the answer that I would have gotten if picking out the 0.8
Can
on the z value.
which table are you using, to look that up?
It was at the table E in the appendage, or the appendix.
I want to just make sure that I'm on the same page with you.
I think that went through me because it was in the negative number corresponding boxes.
Okay, so yeah, I'm looking at table E as well. And
Right.
so, you're looking at 0.9671, and
Uh-huh.
let's see, we don't find it exactly 0.9671.
Right.
Oh, well, actually, no, actually, that is exactly there.
Oh, is it?
Yes. Let me hold up my book.
Okay.
So this is, table
E.
and I'm looking. It's 2 pages, and on the right hand side. So again, I'm using an older version, an older edition of the book.
Right.
So I'm not sure if the page numbers are going to line up exactly. For me, it's on page 647, but that may not mean anything, depending on the version that you're using.
Okay.
But I do find that probability, 0.9671 exactly in the table. So yeah, so go to that table and let's work through this together.
Okay. Yes, I find it.
Okay, so when you find that value, 0.9671, look to the left.
Uh-huh.
And what do you see in the leftmost column?
1.8.
Exactly. Okay, now look directly above the 0.9671.
Uh-huh.
And what do you see in that column header?
0.04.
0.04. So what you need to do is add those 2 things together. So, the left hand, gives you the first 2 digits, the 1.8.
Right.
And then
Right.
When you look up, you get the 3rd digit, which is actually the 100th place, a 0.4. So that, when you put the 2 things together, you get a Z of 1.84.
Right. And that's what I originally got, but I was confused because the shadowed area was on the left of the 0, and I thought that meant that it was supposed to be negative.
So
No, the reason I thought that, so that's why I came up with I subtracted the 9671 from the 0 value and came up with a different number, and it was on the negative side, so the 0.8. So that's why I thought maybe I was doing it wrong.
That's a good question because I'm looking over these problems. Some of them we see an area shaded to the left, and then some of them we see an area shaded to the right, and then another problem we see there's a shaded area in between two values. The best case scenario is when you have area shaded to the left, which is what we have in this problem. Now, when it's area shaded to the left, the value that you look up in the table is your answer. So you only need to subtract from 1 when you're looking for the area that's shaded to the right. So, for instance, if you look in that same section, a couple of problems earlier, like at number 42, we see an area shaded to the right. Now, that's you would not find directly by looking in your table. That's an example where you would have to subtract from 1. But in this problem, number 44, we're good to go. It's cumulative probability, and it's from basically negative infinity up to this point z. And that's exactly the way that your table works. So when it's shaded to the left.
So on problem 42.
Yeah, go ahead.
Like on problem 42, so you subtract that from 1, you don't subtract it from the 0 value?
No, yeah, so let's look at problem 42. So what's the probability that you see in problem 42?
0.0239.
Exactly. And that is a probability that's to the right of that z value. Now, your table is set up to give you probabilities to the left. But, that's fine. Your total probability is 100%. So you can easily adapt that or, convert it. And so in that case, you would take 1 minus 0.0239.
Oh, okay.
You would get a decimal value.
So you don't just look up the corresponding probability then on that one, or standard deviation on that one, or probability rather.
It's not the standard deviation. You know what? Let's do this. I want to kind of show you an interesting property of a normal distribution. Let's say that we do look up 0.0239. So let's go over to table E.
It comes out to 0.6.
0.239. Wait, 0.6? So walk me through, how are you getting 0.6?
I subtracted the 0.0239 from the 0.500, which is a 0 value.
So
see, I think I might not have done it right.
Okay, I think I understand. So I think you are looking at the zero value, which is 0.5. Really, I think what you want to be thinking about is like the total probability, which is 100%. So, so go to table E with me. Don't worry about doing any subtraction. And just look in that table and see if you can find 0.0239.
Yes. Oh, wait, 239. Gosh, I should have put my glasses on.
I have mine on, so yeah.
Yeah. No, I don't see a 239.
Oh, okay. Well, it's there. So,
I mean, it may be there, and I'm just not seeing it.
okay. Well, let me help you find it.
022A.
So 0.0239,
Okay.
since that's less than 50%, it's going to be on the left-hand page.
Right.
And so, kind of glance over at the left-hand page and look around and see if you can find it. They kind of go in increasing order.
What table are you guys looking at?
This is Table E. It's in the appendix. And so this is the table that has your standard normal distribution.
Yeah, I found it.
Okay. Now, what's the z-score that corresponds to that probability? So again, you need to look to the left and then look straight up
Right.
and combine the two.
1.98.
Importantly, it's negative 1.98.
Oh, yes.
Okay, negative 1.98. Now, you'll notice all of the z-scores on that left-hand page are negative. All of the z-scores on the right-hand side are positive, because in the standard normal distribution, 0 is your middle. So that's kind of convenient.
Okay.
That's why we like to use the standard normal distribution, because 0 is your middle. And so everything to the left is negative, everything to the right is positive. So, and remember, 0 corresponds to the 50% mark. So if you are looking at a probability that's less than 50%, so in this case, we were looking at 0.0239, which is less than 0.5. Yeah. So we know that that's going to correspond to a negative z-score. In the previous problem, number 44, when you were looking at 0.9671, that's more than 50%. So it's going to be a positive z-score. It's on the right-hand side. So, okay. So so we have negative 1.98. Now, what I want to point out to you is, let's look at this another way. So if you go back to the original problem, you had an indication that 0.0239 was an area to the right. I'm going to hold up a little drawing here.
Yes.
Can you see that? So this is kind of like what you were presented with in number 44. You've got an area that's to the right that corresponds to 0.0239. Now, to find an area to the right, one way to do that is to subtract from 1. So let's see, what happens when you say 1 minus 0.0239?
Oops. 0.761.
1 minus 0.00239. You get 0.9761. So when you take 1 and subtract 0.0239, you get
0.9761.
Now, I want you to take 0.9761 and look that value up in Table E.
Okay.
Billy, are you following along with this?
Sort of, yeah.
Yeah. Well, okay. So, did you find Table E?
I did.
Yeah. Okay.
Yes.
And so, are you able to find, like when I say, look up 0.9761? Can you find that in Table E?
Yes.
Okay. And so when you find 0.9761, and then you look, to the left.
Mm-hmm. 1.9.
You see 1.9, and then when you look up,
0.8 or point.
0.08, add the two together, and you get positive 1.98. Now, isn't that interesting? Because, look, before, so, here I subtracted from 1, and I got,
Right.
got a probability. I look that up, and I get positive 1.98. Now, notice before, we got negative 1.98. So
Uh-huh.
they're just opposite of one another.
Okay.
So, you've got two strategies here. So when you're trying to find an area to the right, you have a choice. You can either subtract from 1 and then look up that probability, or you can just look up the probability directly, but then switch it from negative to positive.
Oh, okay.
Because it's symmetric. Zero's
Okay.
right in the middle, and this is a mirror image from one side to the other. So you can do it either way.
So basically, if it's below the 0.5, then it should be a negative number, right?
You're correct. That's
Okay.
a really good point. I'm glad that you recognize that, because that's
Okay.
a really important part of understanding this concept of the standard normal distribution.
Okay.
Zero's in the middle.
Okay.
Everything to the right is going to be a positive z-score. Everything to the left is a negative z-score, but it's symmetric. So if you want a probability on the right, you can just look up the one on the left and then switch it from negative to positive.
Oh, okay. Okay.
Or you can subtract from 1 and then look it up directly.
Look it up directly. Okay. Okay.
Either one's fine. And it's good. It's good.
Okay.
Just understand that and to be able to do both.
Okay. Great.
Now, to me, the more complicated is when you want to find an area in between two values. So let's look at an example of that. So let's go back to section 6.1.
Mm-hmm.
And I want you to help me find an answer. Do you see problem 41?
Yes.
What about you, Billy?
Mhm.
So in problem 41, I'm going to just kind of try to recreate it here. You have an area, and again, I'm working on an older edition. In my book, it's 0.4175. Is that the same for you guys?
Yes.
Yes.
Now, so here's what we're looking at. You agree?
Mhm.
Yeah, okay.
Yeah.
Now, in this case, it's a little bit more challenging because we're not finding an area that's completely to the left or completely to the right. It's an in-between problem. Now, how can we use the table to answer this?
Would you still subtract it from 1?
Would you subtract what from 1?
The 0.4175.
So, if it was the total area to the right, I would say yes, subtract from 1. But in this case, we really don't want the entire area to the right. We really just want up until this next z-score, which in this case happens to be 0.
Mm-hmm.
You brought up something earlier, which I think is going to be helpful here. And that is that 0 is the middle point. It's the divider. And, this is symmetric. And so, the total area is 100%, 1.
Right.
And so each half is 50%. So
you would do it from the 0.5? Would you subtract the 4175 from the 5 or 0.5?
You would. Yes.
Okay.
Yeah, you would. So, in this case, I'm going to try to make this, let me put this up here again. From this point, the middle of the curve, from here all the way over, that's 50%. Okay, but we're
Okay.
trying to find the line that cuts off, that separates basically this 0.4175. And so that's not the total area, from here over. It's really just from there to there, to the midpoint. And so
Okay.
this is the 50-50 split. And so in this
Okay.
case, rather than subtract from 1, I think we should subtract from 0.5. So let's do that. Let's say
Okay.
0.5 minus 0.4175.
0.0825.
Yes. And then let's go back to table E. And let's try to find 0.0825.
I'm not seeing it. Am I just blind?
No, it's not there. So that's
Oh, okay. Great.
that's not a bad thing.
So,
Because what we see is that there are two values that kind of would, like I'd say, straddle that. There's 0.0823,
yes.
and then there's another one close to it. And what is that?
0.838.
Exactly. And now, what are the corresponding z-scores for both of those? So for 0.0823, it's negative 1.39. And for 0.0838, what is it?
3.8
Yeah. Now, what should we do?
or 1.38.
We weren't able to find it exactly. We were able to find one value that's a little less than what we wanted and another value that's a little more than what we wanted. And then we were able to map that to z-scores. So what should we do?
Would you average them?
Average. That's a good idea.
Oh.
So the two z-scores were negative 1.38 and negative 1.39. So what did we get when we average those two things?
Probably negative 1.385.
Exactly.
Yeah. Okay.
Yeah. When I hold this up, are you all able to see it the right way, or is it in reverse?
That's right.
Okay, good.
It's right. Yeah.
Okay. When I look at it, it's reversed, so it's confusing. Oh, okay, good. Well, good. I'm glad.
This is probably why I'm not doing very well on my homework. I just assume that, oh yeah, I'm doing this right, and then I get in there and I'm like, I'm doing it completely wrong.
Now, I want to tell you something. In this situation, when you're not able to find the exact value,
right,
people have different strategies, to tell you the truth. Now, my advice, which Maria was at your suggestion, was to just average the two.
Mhm.
You know, people have different opinions about what you should do in this situation. Some people say just pick the closest one, you know, which would be, I guess, the negative 1.39. Some people would say, you know, average the two, which is what we did. There's a slightly more complicated strategy, which involves interpolation, which you say, well, I'm this much closer to this one, so I don't really just want to take the middle value. I really want to pick one closer. And even yet another strategy is to use calculator. And then you can get an exact value. Now,
Okay.
I don't want to speak out of turn because I really need to look at Dr. White's notes because I'm not sure which of those, I mean, that's 4 methods right there. Pick the closest,
Right.
average the two, interpolate, or use a calculator. Those are at least 4 different ways of answering this problem. Where you suggested averaging, is that because you've seen that that was the preferred method for this class?
No, I was guessing.
Okay. Well, all right.
Good job.
So, I will tell you that's the most common strategy.
That was seemed easier to me. So.
But I know that your homework is, you know, graded automatically, and so since my point is, we should probably actually give me a second, and let me just look at the solution, and then I can tell you what the preferred strategy is. Shoot. No, I think if I do that, I might lose you guys. So I just want to say that you're on the right track.
Write down all the answers and
So
pick the one that's closest.
I think that averaging is a great strategy, but I'm going to encourage you to go back and actually, you know what? Let's look back in 6.1 and let's see what your textbook says. You know, everybody has different ways of handling this situation when you don't find it exactly and you're looking at it in a table. So I just wanted to see in the textbook what the advice is. Well, I'm not seeing. Oh, actually, so I'm looking on page, again, I'm looking in the 6th edition of the textbook. So, you know, this is older than what you guys are using. But I see in my book, it says, if the exact area cannot be found, use the closest value.
Oh, okay.
It says, for example, if you wanted to find the z value for an area of 0.9241, the closest area is 0.9236, which gives a z value of 1.43. So for your homework, based on what I'm reading here in the book, rather than averaging, let's pick the closest. Now, again, different textbooks tell you different things. You know, about whether you should pick the closest or if you should average the two. Or so if we were going to pick the closest, which of those is the closest 0.0825?
The 2, 3.
Yeah, and what was the corresponding z-score?
1.39.
Negative 1.39. Yeah. So I think if I were going to put an answer in my homework, I think I would go with the negative 1.39.
Okay. I was looking in the book here because they have the odd numbers listed in the
Yeah.
back for the answers.
Uh-huh.
It says negative 1.39, but then it's got in parentheses negative 1.3885.
Yeah, the negative 1.3885, you would need a calculator to
Uh-huh.
get that. You would not get that from
Oh,
your
okay.
textbook, from the table.
Okay.
You would need
Okay.
technology to get something that exact.
Yeah, and I can't. Technology and me don't work. Well, actually, most technology does, but not those calculators. They confuse me.
Oh, yeah. Well,
I'd rather just write.
honestly, I mean, I do love the technology. I like calculators, but I actually think, if you really understand that table well,
Right.
I think that you get a better kind of understanding of the whole distribution. Uh,
Right.
so yeah, so let's just go with the negative 1.39.
Okay. Okay.
Yeah, that was a good. Those are good questions. I'll point out to you that there are three scenarios here, and I'm going to kind of list them and give you a picture to go with each.
Okay.
Can I ask a question of Marie really quick?
Yeah, sure.
Marie, what prompted you to look for the table in the back of the book? I don't see anything about that.
In one of the examples, it was talking about a table.
Okay. Okay.
And so when I was reading through and looking at the examples, I picked up that there was a table in the back. So that's how I
You smart
pulled the book
girl.
out and
Look
looked.
at you.
No. I kind of have to look at the examples to try to figure out what I'm doing because I'm totally lost on this.
You can tell I haven't listened to the lecture yet. I was just like, oh my gosh.
Okay.
Yeah.
I have to print this
haven't
off
either,
so I can see
so-
what they're talking about. Yeah. Okay.
Yeah.
Okay, so I've got something to share with you guys. Okay, so
Better.
basically it all comes down to three scenarios. And if you understand these three scenarios, you're going to be golden because there really are only three possibilities. Okay, let's start with the first one. So you see in the first picture here, I have shaded an area to the left. And I've indicated that there's a probability, 0.9, and that corresponds to the area that's shaded to the left. This is your best case scenario because that means you just look up that probability and find the z-score. The table is organized for areas to the left. And so you would basically look up, you could add some decimal places, 0.9000. But when it's area to the left, just look up the probability and get the z-score.
Okay.
Let's do that together. Let's find the z-score that corresponds to 0.9000 to the left. And we're just going to find the closest one.
I shouldn't have looked. I had to find the table again.
So
0.9. Good.
Okay. Billy, what did you say?
The 0.1841.
No, wait. How are you getting 0.1841?
My negative 0.9.
So again, we're trying to find the z-score that corresponds to an area of 0.9000 to the left. Now, you're not going to find it exactly.
Okay.
But do you see I've circled there?
Mm-hmm. Well, move your thing up. There we go.
0.8997. Do you see that in your table?
Yes.
Okay, that's the closest we're going to come to 0.9. It's not exact, but so we're just going to go with the closest.
Okay.
Okay.
So what's the corresponding z-score?
It would be 0.128 or 1.28.
Yeah, okay, all right. Now, Billy,
Yeah.
are you with? Does that
I'm
make
with
sense?
you now. I
Okay.
got it.
Okay, good. All right, okay, now. So that's, when you want the area to the left, that's the best case scenario. If you can just look it up,
Okay.
look up that probability, and then find the the z, whichever one, the z-score. Okay, now let's look at case number 2.
Okay.
Here, now I've shaded the area to the right.
Okay.
Okay, and I've said it's basically 0.1. Now, if you want to, you can always add zeros. If you want to make it 0.1000, go ahead. If you're trying to find a 4 decimal number, just add zeros on. Okay. Now, in this case, since we're trying to find the area to the right, that's not the way our table is set up. The table is set up to give you area to the left. So here's where I'm saying that you have a choice. You can either look it up and then switch it from negative to positive, or you can subtract from 1 and then look it up. Now, let's do this. Let's look up 0.1. So you're looking in your table. Now, 0.1 is less than 50%, so it's going to be on the left-hand side. And try to find the closest probability that you can to 0.10000.
0.0099.
Hold on a second. Oh, right. Let me show you in the book now.
Oh, okay.
Can you see that?
No.
Shoot.
Oh, okay.
Okay.
So I'm looking.
Billy, did you see that?
I was looking at
the
0.
closest value I can to 0.1000. Now, it's not there, but I do see 0.1003.
Yes, yes. I
And
see
what's
that.
the corresponding z-score?
Negative 1.28.
Isn't that interesting? Because look at the example we did before that.
Yeah. Oh, I see. Yeah.
Here was 90% to the left. Well, that's the same as 10% to the right.
Right.
And so it's the same dividing line. Now, here, when we looked it up, we got negative, though. But that can't be right. Negative z-scores correspond to areas, less than 50% on the left. Now, notice if you put this piece, if you just kind of move this up, it would complete the curve. You'd have the 100% basically. So I tried to draw it to where there's one dividing line. there's 90% to the left, which means there's 10% to the right. It's the same z-score that divides those. Does that make sense?
Okay.
There's one line where my pencil is that separates the bottom 90 from the top 10. And that is the z-score of positive 1.28. Now, when we looked up 0.1, we were actually finding when we looked it up, we were actually finding this value, negative 1.28, which is the dividing line that puts 10% on the left. If you want the value that puts 10% on the right, you can just switch that from negative to positive.
Okay. Okay.
Okay, so that's the second scenario. So
if you actually subtracted it from one, then you would. If you actually subtracted it from one, you'd get the 0.9000.
Yes, yeah. So we could have just said 1 minus 0.1 is 0.9, and then looked it up this way. Or you can look it up and then switch it. So let's review. This is the best case scenario when you want the area to the left. This is the next best case scenario when you want the area to the right.
Okay.
Now, here's the last situation. What if you want area in between? Now, in this case, I'm going to make a special stipulation. I'm going to say that this is the middle, which implies it's symmetric. .40. It's the middle 40%. Now let's think of something. You've got the middle 40. Any ideas about how we can find the z-scores that will separate out the middle 40%? Now remember, your table is only set up to give you cumulative probability, from the left up to a certain point.
I have no idea.
Okay. Let me add a little something to my picture here. My pencil is the middle marker, right? That's the 50%. Half area is to the left.
Can you hear him, Marie?
No. Not really.
I can't either.
I think your notebook's covering up the speaker.
Oh, okay. I'm sorry. So let me just kind of hold it over here.
Okay.
Okay. So you see what I did? There's a middle marker. That's the 50% point.
Right.
Now I'm wanting the middle 40. Now remember, this is symmetric. This curve is the same on the left as the right, or I don't know which is left and which is right to you guys, but but the point is, this is the middle 40. Now, if that's the middle 40, how much is just this?
20. 20.
Exactly. Yeah. So basically, that says that this is 20% and this is 20%. Now, forget about this over here.
Would you subtract the 0.5 from the 20?
You subtract the 0.20 from the 0.5, but yeah, I know what you meant.
Yeah.
But yeah, so if that's 0.5 up to the middle, and that's 20%, then how much is left right here? That's half, 0.5.
80.
And I'm subtracting 0.2.
To be 80%.
0.3.
0.3, yeah. So this has to be 0.3, because these two things cumulatively are 50%. And so if that's 20, then this has to be 30. There's no other possibility. Now, how do we find the z-score that separates the bottom 30? Well, now you're back to this ideal situation where you're just looking at the probability to the left. So we can just go in and look up 0.3000. And let's try to find the closest one.
.300.
Yes.
3. I see a .3085.
And now, can you come down a little bit? We're trying to get as close as we can to 0.3000. Just so I think we can get a little closer than that.
I have a .3015.
Yeah, perfect. Yeah, that's closer. And that's, I think that's the closest that we're going to get.
Okay.
Yeah. And what's the corresponding z-score?
Negative 0.52.
Perfect. Good job. Okay, so we found, this is the middle 40, and so it's 20/20.
Mm-hmm.
From here over is 50%. Well, 50 minus the 20% leaves 30. So we looked up the 0.3.
Right.
You found a z-score of negative 0.52. Now, here, again, recall this is symmetric. So, this was the middle 40, which, means 20/20. So if this is negative 0.52, what's this guy over here?
Positive 0.52.
That's a freebie. We don't have to look that up.
Okay.
Because it's symmetric.
Okay.
Yeah.
Okay.
Now I'm going to ask you another question. This is like our bonus challenge question. Okay, we're going to reverse things. So in all of those problems, we were starting with probabilities and looking up z-scores.
Right.
I'm going to switch it up. We're going to go the reverse order. I'm going to give you z-scores, and we need to find probability.
Okay.
Okay. Now, you see the difference here? I'm giving you the z-score. I'm telling you what that is. And now I'm asking you, okay, here's my dividing line. It's the z-score 1.645. And notice I've shaded the area to the left. Now, this is perfect because this is the way our table is set up. So I want you to look up that z-score and tell me what's the area that's to the left of that.
0.9495.
How did you find out?
I took the z-score and found the probability number on it.
Now, I'm going to challenge you a little
Is that
bit.
not right?
Yeah, well,
Okay.
I want you to look one column over and tell me what you see.
One column over?
Yes. So you said 0.9495. So look
Right.
one position over to the right, and what do you see?
947.
0.9505.
Yeah. Now notice that those are exactly, I'm sorry. Let me go back here to my picture. I kind of threw you for a loop here. Notice I gave you a three decimal places in the z-score. Your table only goes to two decimal places. So here I kind of forced it to be an average between two. And so, yeah, the two values that you see, the 0.9495 and the 0.9505, if you average those together, you would get 95%, 0.9500.
95%.
Yeah. So
hang on 1 second.
Yeah. So you know that's
Okay.
This z-score that you're seeing, the 1.645, it comes up a lot. I want you to keep it in mind because when we build confidence intervals and we do hypothesis tests, you're going to see this z-score a lot. And I want you to just kind of know that it corresponds to the 95% to the left. Okay. Now, let's switch it up. I've got another problem for you. Now, in this case, change things here. Take a minute and look at this picture. Okay, so I've marked a z-score. So here's the line. Here's my z-score, and that corresponds to negative 0.33. But in this case, I'm wondering about the area to the right. Now your table gives area to the left.
Right.
So let's see what happens.
So
let's just look up that z-score, negative 0.33.
0.3707.
Yeah. So now does that make sense? I'm asking you, does it make sense that this area would be 0.3707?
No.
No. Notice, you know, we've obviously highlighted more than half. The 0.3707 is the area to the left, this over here. So how do we get the area to the right?
Okay. Subtract it from 1.
Subtract from 1.
Okay.
1 minus that.
Can you hear the stream by chance?
Yeah.
Okay, thank you.
So the correct answer is be 1 minus 0.3707, which is 0.6293. So again, you see the parallel. The first problem we did was we're looking for, you know, we were given area to the left. And the second problem, we're looking for area to the right.
Right.
So you see the difference? In the first one, we could just
that makes
look it up directly, and then the second one we had to subtract from 1.
Okay. Yeah, that makes sense.
So let's go to the very last scenario. This is the super bonus question. If you can do this, you can do any of it. I promise you.
I don't know about that.
Okay, I'm going to draw you a picture. And then we're going to say that this is 1.64 and this is negative 0.33. And I'll pull this up. Take a minute and look at the picture there.
Mhm.
Okay, so I have, now notice this is not symmetric anymore.
Right.
So there's actually, if this is the middle of my curve, there's
Right.
more shaded in this direction than this direction. But I've given you z-scores.
Right.
I said this line right here corresponds to negative 0.33.
Right.
And I've said that this line corresponds to the z of 1.64. Now, what I'm asking you all is, how do I find the area in between those two?
Right?
Do you subtract the z-scores?
Subtract the negative 0.033 from the positive whatever you said.
The 1.64.
Yep, that's the one. Sorry.
Is that right? Are we right? Maybe.
I don't know. We'll see.
Let me show you something. So we're going to recycle some information. Okay, this line where my pencil is, that corresponds to the z-score of 1.64.
Mm-hmm.
Now, we've already looked it up. We know that the area that's all the way to the left is this guy. What is
Okay.
it? 9495. Okay, so that's from here all the way over. And now, if I move my pencil down to here, I've put it over top of the line that corresponds to the z-score of negative 0.33. And we've already looked that up. The area that's to the left of that, 0.3707. Okay?
Okay.
Now, what I want is just the in-between part.
So would you subtract those two numbers?
Yes. Yes, you would. When you want an in-between probability, you can just look them both up and then just subtract the smaller from the larger.
So subtract the value of the z-scores,
Not
basically.
the z-scores, the probabilities. So
Oh,
I'm
the
not
probabilities.
subtracting
I
these
mean,
numbers.
yes.
I'm
It'd be
subtracting
like
these numbers.
0.61 something or other.
Let me take 0.9495 and subtract 0.3707. 0.5788. So that's the answer, 0.5788.
Okay.
Which would be 57% or 58%.
Yeah, about 58%.
Yeah.
So I want to give you a quick recap. 3 scenarios. You're given an area to the left and you look up the z-score. You're given an area to the right and you look up the z-score. You're given symmetric area in the middle and you find z-scores. So we did those 3.
Mm-hmm.
Going in the other direction, you're given an area to the left and you look up a z-score. You're given an area to the right, you look up a z-score. You're given an area in the middle where you look up, I'm sorry, I said that wrong. You're given a z-score and you're looking up area to the right. you're given a z-score, you're looking up area to the left. You're given 2 z-scores and finding the area in between.
Which is basically subtracting the probabilities of those. Yeah. Okay.
Those are the only 6 scenarios I think you need to worry about. So in the first 3,
Okay.
you're given probabilities and finding z-scores. In the next set, you're given z-scores and finding probabilities. So you need to be able to go both ways.
Okay.
And then you need to just be able to consider area to the left, area to the right, and area in between, going either direction.
Okay.
It really does come down to just those 6 things. And I don't mean to make it, I'm not saying that it's easy. I know it's hard. But I do want you to know that it really is just 6 things.
Before we run out of time, can you explain how to do question 2 on 6-2?
Question 2.
Because I 6-2. Because I completely am drawing a blank on if I'm doing it at all.
Question 2 on 6-2. And again, let's make sure we're all on the same. Can you tell me how your problem reads?
Teacher salaries, the average annual salary for all U.S. teachers. Yeah.
Yeah. Do you have 47,750?
Mm-hmm.
And the
Yes,
standard deviation is 5680?
Yes.
Okay. All right. And okay. So my advice is always to draw a picture. And I'm going to help you out here. This is 47,750.
Because I think my problem on these questions and why I'm kind of at a block is kind of like Billy was having last week. I'm not sure which numbers go where.
Okay. So I'm going to give me 1 second here to just make a few notes here. And
Wait, that's always Billy's problem. I don't know
Okay.
what.
so, all right. Okay, so here's
Mine too.
here's my picture. Okay.
Okay.
Now I have a normal curve. Now on the bottom, I've labeled it with z-scores. Those zeros in the middle. Here's +1 and -1. +2 and -2. +3 and -3. Okay. Now those are standard normal values, z-scores. Now this particular normal distribution, though, has a different mean, namely the 47,750. So I'm putting those values at the top. So that's the average teacher salary, which, the average corresponds to the middle of the distribution. So it's directly above the 0. Now, in this case, my standard deviations are not 1, which would be the z-scores, but rather the standard deviation in teacher salaries is 5680. Now, so if we go 5680 to the right, that's 1 standard deviation over. If we go 5680 to the left, that's a negative standard deviation. Now, the problem here is, in part A, we're looking for between 35,000 and 45,000. I need to make a few more notes. When you take 47,750 and you subtract 1 standard deviation, which is 5680, I want to just add another note here. That corresponds to 42,070. Give me just a minute to get this set up.
Okay.
Okay. you see the value in the middle here that we discussed, that's the average. That's right above the zero. That's the average salary, which is $47,750. Now,
Okay.
if I go one standard deviation to the left, each standard deviation is 5680. So if I
Okay.
subtract one standard deviation, I get 42,070.
42070.
Yeah.
Okay.
Now, if I go two standard deviations, I would have to subtract that amount again, and I get 36,390. If I go three standard deviations, I have to subtract that value again, and I get this, 30,710. So
Okay.
these are z-scores: one standard deviation, two standard deviation, and three standard deviations, and they're negative because I'm subtracting it. And then here are the values that correspond to the problem that we're working on currently, 47,750, and then these three values. And notice all I'm doing is subtracting this number repeatedly, one time, two times, and three times. Okay, now.
Okay.
Does that make sense? Billy, are you with me on that?
Yeah.
I'm with you, but I don't understand how that's going to find the probability.
Okay, so now let me add another piece of the picture.
Okay.
In part A, we're asked to define the probability that corresponds to between 35,000 and 45,000. Now, 35,000 and 45,000. Now, this line is 35,000, and this line is 45,000. We're looking for the area in between. Now, why did I draw them there? Well, okay, the 45,000 is less than the average, which is 47,750. So I drew that line just a little bit, to the left of it. And I'm not trying to find an exact position. I just know that it's to the left of this. But now it's not one standard deviation over, because that's 46 and some change. And the reason I drew the 35 here is because I'm looking at the values that correspond to certain multiples of the standard deviation. Okay, now if I want to make this problem look more familiar, I need to convert these to z-scores. So I know that the corresponding z-score is somewhere between -1 and 0, and the corresponding z-score here is somewhere between -3 and -2. But I need to find something more exact. So we need this formula, x minus mu over sigma. Now, x is a particular value. Mu, that's the Greek letter, means the mean, the average, and sigma, the standard deviation.
Is a standard deviation.
Yeah.
Okay.
Let's find the z-score that corresponds to 45,000.
I'm sorry, what?
One second. Let me write a few things down, and then I'm going to answer your question. Okay. I filled in some values. I'm trying to find the z-score that corresponds to 45,000. To this line where my pencil is. Now, in order to find that z-score, I use this formula, x minus mu over sigma. The x is my 45,000. Mu is my average. And sigma is my standard deviation. So can one of you do that calculation for me?
Sure. Negative 2750.
No, hold on a second. Now you need to divide that then
Oh, divide it.
by 5680.
Oh, by the, yeah, I didn't do that.
Okay.
That is 0.484.
Let's just round it at 2 decimal places.
Okay. 0.48.
So this line right here, of 45,000, in terms of a standard score, a z-score, it's negative 0.4.
It would be a negative.
Now, we
Okay.
also need a z-score for this guy, 35,000. We're going to use the same formula. But in this case, we're using 35,000.
Okay.
So let's do that together.
Is it negative 2.24?
You got it.
Okay.
Yeah, so we have negative. So now let's look at our picture here. We have 2 z-scores, and we're trying to find the area in between them. Now, I'm gonna simplify this. Draw another fresh picture. So you see, we've reduced the problem to just this.
Okay.
Now, have we seen that type of problem before?
Yes.
Absolutely. That's the type of problem that that we did before.
The super duper hard one.
Right here. Yeah. Where I
The
said-
super duper
where I
bonus.
said you're trying to find the area between 2 z-scores. So we've reduced this problem down to something that we already know how to solve. The area
Okay.
between 2 z-scores.
So then we would go back to the table in our book and find
Yep, table.
those z-scores and
You're
or
gonna
the
find-
probabilities.
The probabilities.
Yeah.
And then subtract the probability.
You're going to
Which
find the
is-
area
yes.
from here over and the area from here over by looking them up in the table, and then just subtract the 2.
Okay. Okay.
And I got 47%. Is that right?
That looks
Ish.
reasonable. I know it's less than 50%. How do I know it's less than 50%?
Because of where it fell
'Cause-
on your
Because look at our picture.
Crap.
That's why it's helpful to draw a picture.
Yeah.
right.
This area that we have highlighted is less than half the curve. Now, it's most of this left-hand side, but it's not all of the left-hand side. So your answer to me
Right.
makes sense because it matches up with my picture. Where I've
Okay.
shaded most of, if I give you one piece of advice, draw a picture. I
Okay.
cannot tell you how many times that has saved me from making a mistake. And I still do it. I'm not just doing this for you all. I'm doing this for me. Pictures are what and I've been doing this for 20 years. I still draw a picture every time.
Okay. Okay.
Uh,
That
but
makes sense.
that's also just I'm just kind of I need a visual, or else I get confused. So that is actually
I was completely confused on all of that because the formula they gave on some of that was like, oh my God, I don't even know how to do that.
the trick here is to take the complicated problems and reduce them down to an easier problem, something you've already done. And we have definitely gone over our time, so that's fine though. This is a hard section,
Oh, yeah.
but it's a really
Sorry.
important section. Everything you do from here on out, confidence intervals and hypothesis tests, depend on the normal distribution. So really take your time and try to understand this, because everything else from here on out depends on the normal distribution.
Okay. Okay.
Okay, all right, you guys have a good night.
Thanks.
Thanks for joining.
Thank you.
All right, bye.
All right. Bye.
Marie?